Welcome back. You almost made it through the second day of our course. So to keep you entertained, we planned for the last lecture of today an overview on privacy technologies. You also get a more advanced lecture on privacy with some more advanced techniques in the next days. I also want to briefly announce a program swap. So 2 talks will be swapped due to unavailability of a speaker on some days. So tomorrow, the last lecture will be given by Ilias Chansos on regulation, and Peter will actually his lecture on telco security then on Thursday in the slot. I will put it online on the website as well. People asked me about slides, so the slides are being made available, although some industry speakers, like Boyan from Swift, are not allowed to give their slides, so you have to pay extra attention in the talk. But you're not allowed to take pictures, okay? That's for tomorrow, or take notes, exactly. But so, in most cases, we will actually make slides available, and also recordings will appear on YouTube for some speakers who allow this. Again, some other people don't like to be recorded, but if it's allowed, we do this, and I think this one also will be recorded. So please take it away, Debo, for the last talk of the day. Thank you.
Hello, everyone. This is going to be an overview talk about privacy. I'm not going to go into details of specific tools and techniques. I'll try to give you an overview of existing problems and why we need privacy and actually what privacy is. And feel free to stop me anytime and ask questions if you have. But I promise you I will not hold you back after 5:30. So, as I mentioned, I want to give an overview of what privacy is. So, privacy is generally many times an abstract and subjective concept. So if you can ask different people, and different people might have different perspective about privacy. For example, any volunteers who want to explain what they understand by privacy? Any volunteers here? If you don't volunteer, I will pick randomly, so it's better to volunteer. Okay, I will pick you. Yes, what do you understand by privacy? Or if you have to achieve privacy, what do you want to have?
Or information or matters that are personal to me.
Okay, and anyone else? What about you?
Just information that I don't want publicly available, that stays secret.
Okay, that's a valid example. What about Isogen? So yes, you can ask different people about privacy, and they will have different opinions. And also, many times it is intertwined with social concepts like freedom, dignity, or autonomy. For example, in some cases, you might want some information to be private, or depending on the social context, you might think that something should be private, and in other contexts, you might think something should not be private. For example, in some societies, they might feel that when you are renting an apartment, your criminal history should be available to the landlord before they decide. But some society might think, no, if they have served their time, they are not a criminal anymore. They are free in the society. So why should that stop them from getting an apartment? Or why should that stop them from getting a loan or a job? So it depends. Many times it depends on the social context. For example, should the current address of a person who is applying for a loan to a bank be private? Any volunteers to answer this question, yes or no? So for example, what could the bank do when they're evaluating the person with their address? What do you think? Yes, and what can be the implications of that if they look up where you live? Yes, and what information can they get from the neighborhood?
Crime rates, income level.
Yes, so depending on the neighborhood, they can profile you. So for example, many times we don't acknowledge it, but many times people of color, they live in a different neighborhood compared to people of not color, and then generally statistically they might find that those neighborhoods have more crime rates, low average income, and based on that they might think that you are a high risk for loan, and that means you are profiled and discriminated based on your address. And then the question is, then the bank probably needs to know your address, to verify your address, that you are a citizen of the country or you have a valid address to provide you a loan. But again, should the bank be profiling you based on your address? So depending on the context, the notion of privacy changes. So even in research field or engineering field, depending on whom you ask, the perspective of privacy changes. For example, suppose some research institute or company spends millions of dollars to learn a machine learning model, and then when someone uses the model, should the model be public? Probably they want to protect the model. But if they want to protect the model, that means all the classification needs to be done by collecting the client data. But then do you want to protect the privacy of the client data? So depending on whom you ask and what's the object of interest, the perspective of privacy changes. And before 1980s or before 1970s, when there was no internet, so I'm slightly going back in history, like X-Men movies, but just stay with me for this part. So before the internet was there, everything was physical. So things like any information any documents that are basically physical papers. And now with internet, you have them online. And then basically, if you have conversion, they were face-to-face. Now, face-to-face conversion, it's difficult to record unless you actually record it. And then you have to keep the recording. But Skype or Zoom, they are easy to record. And then emails, they stay forever. And then files in digital archive, they are basically easy to redistribute, easy to share. Even when you're making payments, cash payments are difficult to keep track of. But when you're making payments with credit cards, the record is there forever with Visa or MasterCard and your bank. Similarly, with location tracking, if you're using some location app that tracks your location, that data is there forever with the app server. And now, before internet, you had friends whom you meet in person. Now you have social networks, and basically then you have social network graphs. And I can give many such examples. The specific examples are, in this case, not important. What's important is that when you digitalize things, it's there forever. And it's easy to copy. It's easy to redistribute. Anyone, and if it's redistributed to someone, they can also copy and redistribute. And then once this is distributed so much, then it's difficult to destroy as well. And then if you have all the information available online, then you can collect those information, you aggregate those information, and then you can profile users. And even sometimes you learn things that probably the user themselves do not know about them. So for example, they probably do not know that they have some food habit, but they just do it implicitly. There was a famous case in the US where it was realized that the study showed that Walmart knows if someone is pregnant before they themselves know it, just based on their purchasing pattern. And once the information is on the internet, it's never forgotten. It's always there. And then the question is, then how do you protect this information that is always there, that is easy to distribute, easy to copy, and never forgotten? And that's why when we moved from physical to online world, privacy became more important. And for many, these are some example scenarios where privacy is at most concerned. For example, database systems, because they're dealing with actual data. And then machine learning applications, because they are always collecting data to learn their model, and then using the model to classify, again, user data. And that means you are dealing with a lot of data there in machine learning applications. And that's why nowadays, especially with the new ChatGPT and OpenAI, it has become even more a serious concern that if, like what ChatGPT learns from your behavior, and then how does it, if it will actually protect the information in its learning set. Blockchain and cryptocurrencies also are concerned with privacy, and because everything is in public in blockchain, and we are dealing with their financial data as well. Communication system is another thing. For example, all the instant messaging systems, even calling systems, they try to protect privacy and defend against surveillance. Many times you are concerned against surveillance, and you want to protect privacy in those scenarios. Web services as well. Biometrics is important in the sense that because it can infer other information about you, your medical, for example, it doesn't, even if someone doesn't have access to your medical record, from your biometrics, they can infer information. And that's why biometrics are sensitive. And also sometimes humanitarian cause. For example, someone received humanitarian aid. That information itself could be used against them to profile them. Because if, suppose Red Cross is using a local financial agency or bank to distribute aid in a location, and then that bank has that information forever. And when 20 years later, they go to the bank for a loan or something else, the bank might profile them as high-risk client. And that means they were already suffering because of whatever happened 20 years back, and now they are again struggling to get back in the society because they are profiled based on that information. And many more. So there are many definitions of privacy, or many formulations of privacy by legal experts, by social scientists, and from technology perspective as well. The first formulation of privacy came from two legal experts. That was in 1890s. It was concerning, at that point, photography was just invented. And that means when people go out, someone can photograph you. And that became a concern for people that, okay, I don't want to be photographed when I'm outside. And that's why they made this statement, the right to be let alone. So if someone doesn't want to be photographed, they shouldn't be photographed. Probably they are having a personal family time, and if they're photographed, that means basically you're violating their privacy. And I don't think this is just relevant in 19th century. This is relevant till now. Paparazzis are everywhere. For example, think about celebrities, how their lives are, how they have, what kind of precautions they have to take to just avoid paparazzis. So this is still relevant, but this was when people first came up with some formulation of privacy. And then privacy field picked up more around 1970s and 1980s after the internet came. This is, so basically, Westin is another social scientist. He said, the right of an individual to decide what information about himself should be communicated to others under what circumstances. So that's how, he formulated privacy. So basically, you are deciding the circumstance, and you are deciding the information and how that is being communicated. And a similar notion of privacy, or which was adopted in German constitution in 1983. It was called information self-determination. So that also has the similar notion. They are similar. I'm not going to go through them. You can read them later. And then there are many other formulations as well. this I want to explain a bit about this because this was really important because it gave a different perspective about privacy. So this notion said define privacy as contextual integrity. So as a person, you should be able to define how you would be presented in a context. And then basically, so to present yourself in a context, you should be able to control what information is presented in that context and how that is presented. So you should have control over the context. And then once you have given the information, then you have to control the flow of the distribution. So suppose I give how I lead my life in social circles and how I lead my life in my professional circle, they might be different. And what kind of information I share with these two groups, they might be different. And I don't want that, suppose I share something with my social circle, I want to make sure that that information doesn't go out of that circle. So or if that goes out, it goes out in a certain form. So that's the information flow. So sometimes in the definition that Nissenbaum gave, she did not explicitly mention what kind of, she called it norms. So norms, basically first norm was appropriateness, like what information is presented. And the second norm was control flow. And sometimes these norms can be explicit, like for example, if you're talking about confidentiality. If I'm talking to someone, I want only that person to know that message and no one else. That can be explicit, but sometimes it can be implicit. For example, no one should know about my food habit or my internet access behavior. And there you are not always explicitly specifying the norms. So when we actually design systems, we have to sometimes figure out how to concretely define this privacy property. And then this is more about surveillance, but I still want to talk about this because this has a different flavor of defining privacy. It's less privacy and more surveillance in the sense that it defines it defines privacy or surveillance from an economic perspective. So what it says that, suppose you are using some service on the internet. If you are not paying for the service, that means you are not the customer, you are not the end product, you are the raw material. So for example, consider Instagram or Facebook. The content you are watching is not created by Facebook. The content you are watching is created by other Facebook users. And what you are posting, what pictures you are sharing, they are being watched by other Facebook users. So that's how Facebook is engaging users. So basically, one user is creating content for other users. So basically, you are providing the content for Facebook in general, or Instagram. And then, how are you acting as a raw material? So what Facebook is learning, but of course, from that content, Facebook is learning something, but that's not how Facebook is generating revenue. They are generating revenue by learning your behavior and selling those behavior. So Facebook or Google's main business model is ad. So how would the ad agency provide targeted ads? And that's by learning your behavior. And then based on that learning, they can provide targeted ads. And that's why they will pay Facebook. So that means you are acting as a raw material when you are using those social networks. And then based on your behavior, they are earning money. I think I mentioned this, behavioral prediction patterns. So basically, that is creating the new type of market. So basically, where your behavioral pattern is recognized by Facebook and sold to the ad delivery agencies. And so this is more about surveillance, and this is a recent perspective about what you should, or what actually, what kind of privacy you gate when you are using such kind of social networks. And actually, when after GDPR, when European government agencies says that Facebook or Google cannot merge the data from Europe and US together for learning purposes, actually Facebook many times threatened to actually pull off their business from Europe. So that's how much they are bleeding just because they could not merge the data. But that's all good. We have many philosophical understanding not understanding, but formulation of privacy. But we have to finally design systems. And when you have to design systems, we need concrete specification. We need to have concrete notion about this is the concrete property, and this is how the property is defined, and this is how to measure the property. And when you design a system, this is how you evaluate that this is how much the property has been achieved. And so that's why you need concrete technical definitions. One example could be entropy. This specific definition is not important. What I want to say is that in this case, this is measuring a specific property, anonymity, in terms of entropy, which is saying, okay, you have entropy 10, means basically you are probably hiding among 2 to the power 10 users, or probably it basically represents how many you have done, certain action has been done by you or many other users. That's what entropy represents. And that's a concrete measurement. And then if you ask me what I understand about privacy, I'd probably give you something like this, which is more mathematical. And I would request you to ignore this, because even it took me a long time to understand this definition. So the main question that remains is, you have this social understanding or legal understanding of privacy, and you want to design a system where you need really concrete notion and a way to measure that notion. That this is with this probability or with this much guarantee you have achieved this privacy. And how do you do that? And there seems to be a lot of gap there till now. And for example, many privacy problems we know where we don't know how to evaluate or measure the privacy. For example, still we don't know how to technically measure surveillance, or how to technically measure or evaluate fingerprinting attacks. And still there is a lot of research effort that needs to go through or happen to actually close this gap. And then even if you have these properties, then there is a question of how do you translate these properties into designs. And many times it's almost impossible to perfectly achieve those properties. And to actually achieve, that means when you actually provide certain formulation of privacy, or to have an understanding of privacy, you need to understand the social expectations, the legal framework based on which you are designing the system, as well as what is technically possible and not possible. And all of these three needs to go hand in hand. Any questions here till now? And I might have briefly mentioned that privacy comes with a cost. So for example, you have a system, if you want to implement privacy intuitively, you have to either make it more expensive. For example, you need to do more computation, or you need to have additional mechanism in place. Either that will make the software difficult to use or difficult to implement. And that means the usability might be reduced. So for example, if you want to, you have all been to the password session. You realize that to secure password, you have to slow down the password evaluation. And that means you have to now, instead of waiting for a few milliseconds, you have to wait for 1 second for the password verification to go through. That means you are reducing utility. And now, to implement privacy, you need to have development cost. You need to employ now privacy engineers or software engineers to actually implement those privacy features. And probably for no additional cost, because no additional revenue, because who would want to pay for privacy? Now there is GDPR. With GDPR, you might say, okay, if you don't implement privacy, then you would pay fine. But otherwise, you cannot sell privacy. You cannot sell that. Instead, if you have a feature and versus if you have to implement privacy, you can sell the feature much better. You cannot say, okay, I have privacy, so it's much better. And so always, if there is a startup, they want to quickly roll out their new product, new service, new software, they would implement the feature first rather than the privacy part. And I already mentioned that it's not always profitable to implement privacy. And that's where the GDPR actually came into picture recently. And GDPR actually puts some regulations to protect privacy. I'll not go into the details of GDPR or what they say, but what now it not exactly forces, but if you don't follow GDPR, you have to pay fine. And basically, that's why now companies are forced to put resources to achieve privacy or to make their software or system privacy preserving. And basically, it also provides protection against surveillance, at least from a legal framework perspective. How do you implement that, or how do you verify that if every company is actually following GDPR or not? That's a different question. And of course, since privacy violation is cost money, you can hope that the companies will invest in privacy now. So now we can hope that since GDPR is there, everything is solved, right? But we have to actually technically implement them. And now I'll talk about some of the historical, I would say, blunders when they tried to implement privacy and how that can be mitigated. So this was much before GDPR, but this happened in 1997. One insurance company, they wanted to publish some data set. Of course, this was an insurance company. They had medical data, and medical data could be useful for research or other financial things. For example, if pharmaceutical can learn from the data to improve their medicines. So what they did was they removed the name from the data and said, this is anonymous data, so this is fine to publish. And they published the data. Great, right? But they did not realize that people can have access to external databases, for example, voter list. And voter list have also people's data. And it seems the zip code, date of birth, and sex, they are quasi-identifiers. What quasi-identifiers mean? That means they can uniquely identify a person. They can; those are unique for a person in the list. And in this case, for 87% people, these combinations, zip code, date of birth, and sex, were unique. That means immediately 87% people were de-anonymized, and their medical records were public. And what was the bad assumptions that Group Insurance Commission made? That it's enough to just remove the unique identifiers. They did not think that there can be quasi-identifiers. And then people suggested that, okay, you can probably avoid this by using something called key anonymity, and probably future solutions would use key anonymity. Then AOL, they did not learn from the previous example. This happened in 2006. And AOL was a search engine. Probably you don't use them now. And for a valid reason, you don't use that anymore. They went out of business eventually. So they released a lot of data about their search data. And what they did was instead of removing the name, they just substitute the name with the number. And they thought that's enough to anonymize the dataset. However, that means all queries from the same user could be linked together, and they can be profiled. And of course, you still have external dataset to actually figure out things. Actually, New York Times was able to identify that this specific user was Thelma Arnold, and based on the information, for example, sometimes when you query things, that reveal information about you. So for example, restaurants near Leuven would reveal information that you probably live in Leuven. If every week before Sunday, you search for barber shop in Leuven. That means probably you get a haircut every Sunday. Every Saturday, you search for Chinese restaurants. That means probably you go to Chinese restaurant every Saturday. And also, you can cross-reference with external information like phone book or voter list, all those things. And what was the impact of that? That means for most users, you can now profile them, their, I don't know, their medical conditions, their mental health, their sex habit, their other lifestyle issues, lifestyle choices, everything, or most of the things. So eventually, AOL went bankrupt, and we don't use the search engine anymore, and AOL doesn't exist anymore. And then that basically introduces the question why our search data are so hard to anonymize, and what could AOL have done to reduce the impact of de-identification. Probably the answer to the second question is easier, that don't publish the data. That's an easier answer, but probably you sometimes have to publish the data because research or because of other purposes. And probably AOL could have learned from the previous example what Netflix did in 2009, and they used k-anonymity. Probably many of you know the Netflix scandal. They basically, at that point, Netflix was not just a streaming service. At that point, Netflix was a movie renting service. So you could you could take a Netflix subscription and you can get a DVD delivered to your home to watch the movie. And then people would rate the movie, and so Netflix basically published the record of movie, rating, and date, and they basically made sure that this data is uses something called k-anonymity. That means every item that you can find, there are identical at least other k-1 items. And then they said, okay, we are anonymizing the data based on well-founded theory, so it should be okay. However, there's some people accessed IMDb dataset, and then basically, if you have rated a movie on Netflix, probably you have rated the movie on IMDb almost at the same time. And that means, and if you have rated the movie 8 out of 10 on Netflix, you are not going to rate the movie 2 out of 10 on IMDb. So from that, you can actually infer, since IMDb dataset is public, you can actually infer who have rated what on Netflix, and that means you can also infer who have watched what on Netflix. So that means they have, ideally, this information that what you are subscribing or getting from Netflix or watching on Netflix should not be public. That information is now revealed. And this basically, what they did not consider was that there can be arbitrary external information. And that is something they failed to consider. And that's why this was a problem. Actually, figure 4 is just, I took the figures from the paper. That's why I did not change the number of the figure. So this shows that how many, depending on how many movies you have rated, how easy it is, or what's the probability that you could be de-anonymized. To summarize the first part, so it is not easy to achieve privacy. Even sometimes the countermeasures that you think are legitimate, that you think are valid, could be actually leaking information and could violate your privacy. And that's why for most of the applications, when you want to ensure privacy, you need to have a critical privacy analysis, like for the end-to-end application. Now, I will take an example to actually try to understand how easy or difficult it is to achieve privacy. So let's consider this example scenario. Suppose there is a bank, KBC, and KBC has many clients, and the bank outsources its analysis for to different firms. For example, the bank wants to analyze what kind of loans should be better suited for people, or what kind of offers they should provide next. For that, they need to do some data analysis. And also, they need to protect against, for example, intrusion or malware, those kind of attacks on their server. So probably they employ some security firm. So they need to share this client data with those firms, security firm and data analysis firm. And then the question is, what kind of privacy requirements should be there? It's possible that when you are accessing the bank, you are basically using the internet. Anyone, your ISP or someone else could be observing the internet links. Also, the bank, when sharing with these firms, they are also probably using some internet connection or some network link that could be observed or monitored. And sometimes the bank might not completely trust this security firm or the external firms. For example, the bank has all the client information about all the transactions. If it just hands over the data to the other external firms, the bank doesn't know if the firm will use the data only for the purpose intended for the bank, or they can use the data for other purposes as well. They ideally don't want the data to basically go forward to someone else. Similar for data analysis firm. And sometimes some other users might be malicious. So for example, some users might try to get access to accounts of other users for financial gain, or just to check how much money others have, or get control over some of other accounts. And sometimes the users might not completely trust the bank with all information. For example, yes, if you want to access the bank, and bank services, you need to authenticate yourself. But should the bank know about you are using the bank services from, for example, Leuven, or from somewhere in Germany, or from somewhere in Aruba? The bank doesn't need to know that. And then basically, what are the basically privacy goals here? Probably one is communication privacy against network attackers. So if all the links could be monitored by, all the network links could be monitored, or they could snoop the links, they could try to modify the packets, all those things. And for the bank, probably the bank wants to protect the client's privacy when the bank is sharing the data with the external agencies. And possibly protection against malicious clients. And of course, protection against external attackers. For example, probably a third-party hacker might want to attack the bank to get access to the accounts, and so on. And many more. Any other things that you can think of that the bank should protect, or in general, this system should protect? Okay, if there are no volunteers, we know the rule. What about you? Do you think these are exhaustive list, or there are more things that the bank should protect, or this system should protect in terms of privacy? You can say, okay, I think this is fine. There is nothing more. Okay. Anyone else? Yes. some employees might be, basically what do you call that? I forgot the technical term. So they might be helping the external hackers, or they might try to gain access. Yes. Anything else? I think those are the fair amount of lists that we need to protect, and still probably we'll see that probably will not achieve everything. So let's talk about the communication requirements. So communication between client and bank needs to be protected. And basically, to protect the privacy of the communication, you typically need confidentiality and possibly anonymity for clients, some cases. In case of bank, probably you might think, okay, anonymity might not be required probably because the bank needs to authenticate clients, but probably it's not a bank, it's some other service. So probably in that case, you might need anonymity. Probably you might need anonymity in the sense that even though the bank should be authenticating you as an user, but still shouldn't be able to know which IP address you are using to access the bank, or what kind of laptop, or you are using a desktop, or what version of operating systems you are using to access the bank. Access control is an important part because the bank don't want any other user to get access to some other user's data. So one user should be able to access only their data and what they are intended to access. And employees, of course, employees should not be able to access random users' data, and there should be strict protocols or strict regulations in place of what they can access and how they can access and how they can use the data. And probably there are many other things. And also, when the bank is sharing data with the other external firms, you need to protect the privacy of the data. In terms of, for example, privacy of the data means the bank wants to share the data with the third party. So of course, the bank doesn't, so maybe the bank is sharing different data with the security firm and different data with the data analysis firm. So for example, security firm might not need the exact customer data. They need to know how the bank infrastructure is set up. And the data analysis firm might need some aggregate data for the customer. They don't need to know the specific customer data. And you, of course, want to protect the anonymity of the clients if you are outsourcing your data. Basically, it's equivalent to publishing your data. And then this external third party should not be able to profile a specific user. They might be doing outsourcing for other companies as well. For example, if you when you're browsing website on a browser, you access Facebook, and probably you are in Google, you search hotels in Italy, and then when you access Facebook, you see ads about hotels in Italy. Then basically they have probably a shared framework in terms of data analysis, and then it's important to protect the identity or protect the anonymity of the users when you're sharing the data. And of course, access control, basically what the each data analysis firm could access. I will not brainstorm about what other things could be protected here, but let's just see what happens with this list. So first thing I mentioned, communication privacy. And one of the, communication privacy, one major thing I mentioned is confidentiality. And I think you have listened to enough about public encryption, about how things work there. I will not go into the details, but generally, yes, you need to protect the confidentiality of the communication. And I also mentioned that when you are protecting the privacy of the communication, you also need to protect the anonymity sometimes. So it could be to basically to have freedom of expression. You are basically posting to a service, or suppose you are posting something about your political opinion, or you're posting related to your habit. You might not want to reveal your identity. And there are existing anonymous communication networks. For example, you can use Tor. For today, I will not go into the details of Tor, But in the next privacy session, I will actually explain how Tor works. But basically, in a nutshell, it basically reroutes the packet through different servers and then tries to hide the actual source or the actual IP address. And then I also mentioned access control. So in case of access control, you need to, one part of access control is authentication. I think that also is covered in one of today's lecture. You can have passwords, and then different passwords have different strength and weaknesses. And then you can have enterprise authentications based on devices or smart card. You can have two-factor authentication. And also, you need to have access policies. For example, a client should be able to access only their data, not anyone else's data. An employee should be able to access data that are relevant to their purpose. And to implement access policies, there are different techniques. For example, role-based access controls, views, virtual private database. I'll just put the terms there. I'll not explain what they are for today, but in case if you're interested, you can just look up those terms. And another major dimension is data protection. So in case of data protection, I mentioned confidentiality of the communication between the bank and the firm, data analysis firm. And when you share the data, you need to anonymize the data, and also access control. So we have already talked about access control and confidentiality of communication. So I'll talk a bit about data anonymization. How much time I have left? So generally for data anonymization, there are many techniques of data anonymization. I already mentioned one, k-anonymity, and I mentioned why it fails. There is another technique, although I'm calling it differential privacy, actually the technique is adding noise to the data. So differential privacy is a notion of measuring privacy, and the technique is adding noise. For example, suppose you have some data, you want to publish the data. You don't publish the data as is, you add noise to the data, and then you try to measure privacy using differential privacy notion. And then the noise could be a Laplacian noise or a Gaussian noise. There are different noise adding techniques. And different techniques provide different kind of differential privacy guarantees. And there is a lot of existing works that shows how to add those noise to achieve certain differential privacy guarantees. But when you use such kind of differential privacy techniques, that means you are adding noise. And if you're adding noise, that means you are reducing the accuracy of the results. And sometimes that might lead to even misclassification of the information. So in the first image, this is a clear image without any noise. Second image is basically you take a picture of the image and then basically ask the machine learning model to classify the image, and it classifies it correctly. It's a washer. You add some noise with epsilon equals to 4, and then suddenly it is, with certain probability, it is classifying this as a safe, and with less probability, it is classifying as a washer. And you add more noise, then it doesn't even classify it as a washer. So the more noise you add, the more erroneous the result is. That means you are basically introducing utility versus privacy trade-off. And then the question is, what is a sweet spot? Where do you actually set the epsilon? And then people suggested alternative, which is using fully homomorphic encryption, or sometimes MPC, but MPC for you need multiple parties. I'll just explain the fully homomorphic encryption part. So in this case, basically, the client doesn't give plain text data. The client sends encrypted data, and you do the operation on the encrypted data, and then you compute the result on the encrypted data, and basically, the encrypted result is given to the client, and basically, you only decrypt the final result. So you are doing aggregation, all the computation on encrypted data. That means you don't, while doing the computation, you don't see the data in plain text. And that's why your privacy is not broken. in one of the sessions, Cypriya will talk more about computation on encrypted data. But this can provide more privacy, but that means this is more expensive. So probably you are adding 200 times more computation overhead. And do you always want to do that? That might be really expensive for the server to deploy. And that's why many times people actually don't prefer to use such techniques. And also sometimes we need to combine this with differential privacy. For example, what if the output of the computation needs to be used by someone else? So for example, in machine learning scenario, you first train the model and then use the model to classify data. Classify or using for classification and regression. Now, using FHE, you might protect the user data during classification and regression, but still you need to protect the privacy of the model. You need to protect the privacy of the training data. And in that case, you might still need to achieve differential privacy. And then that was a simple example. Let's make the example more complicated. So let's consider a hospital scenario, which has many clients, which are patients. Then they have cloud servers. And then there is a data analysis firm, which is doing the technique. And then they use Amazon AWS for computation outsourcing. And the data analysis firm has its own clients. Then the question is, how do you design this system? I will not solve this problem. This is something you can think about later. Generally, the more number of parties in the system, it becomes more difficult to analyze privacy and to ensure what kind of techniques you need. And things become more complicated when you use location data. How many of you use use Strava or Fitbit or any kind of health application? Only 3 people? Come on, guys. Please speak the truth. So what happened was a few years back, so these things, actually you can track people's location from there. For example, if you are using Strava, you can track others that, okay, this is how much they have run, this is their trajectory, and so on. And even a course dataset can actually enough to uniquely identify each person. So what is the probability that 2 people would start running at the same time? They will take the exact trajectory, same trajectory. So that means there is always uniqueness, even if you use data as coarse as just your mobile tower and probably 1 hour spatial difference. And still, you can uniquely identify people with only 4 data points. And what happened was, there was a hidden CIA base or military base. And then you see military personnel who were using the app. They would go for a run. And then you see the heat map on the app. And you can realize there is nothing there. And basically, many heat map started from this location. And that means probably there is something there. Probably people are living there. And that basically revealed a hidden military base. And then US Army banned US military personnel from using these kind of apps. So if you are using such apps, be careful, because these can be used, for example, to track you down, to find where you live. If they want to really stalk you, these can really help. And basically, that's why this is when you are considering things like Internet of Things or smart cities, you are sending location data, and that becomes really tricky to achieve privacy in those scenarios. So that's about it. The main takeaways from this 1 hour talk is that privacy is important, but many times we ignore it for financial reasons, for not enough incentive. And sometimes not just data privacy, but communication privacy is also important. And sometimes it's also important to protect the metadata. And privacy always comes with a trade-off with usability or a cost. And there exist many tools to improve privacy, but most of them are often imperfect. That's all I have. I can take questions if you have. Probably I'm 1 minute over time, but if you want to have questions, I can take them. But others are free to leave.